Okay, thanks everyone who's joined us so far. We'll have a few more people trickle in the next few minutes. Realized I have started on the wrong slide here. Not that you really need to know what today's date is, but as you probably saw in our email, the agenda for today is for us to give a brief intro from the Rocky Mountain Carbon Leadership Forum Hub. Then we'll have a moderated panel next with RMI. And actually, I forgot to change our agenda. I see Victoria giving me the death stare because I didn't do my homework. Believe me, I changed the rest of the presentation, but we have Charles Cannon and Lachlan Wright from RMI here to present on their concrete solutions guide. So sorry, guys, for not updating my slides from last time. And then we'll dig into a Q&A after this. So I'll start with a welcome from the Rocky Mountain Carbon Leadership Forum co-chairs. You can see Victoria and Jim's little faces on the Zoom screen. Hopefully you'll see all of us in person for our next meeting. We're working on that right now, and we'll have more info coming up soon. But as the co-chairs of the Rocky Mountain Hub of the Carbon Leadership Forum, the three of us volunteer to basically organize people who are interested in embodied carbon in our community. With Zoom as a possibility, our community has expanded quite a bit, but we're focused on the Rocky Mountain region, largely Colorado-based. What is the Carbon Leadership Forum? Just a very brief overview. It's an industry academic collaboration hosted at the University of Washington, focused on issues related to embodied carbon. You can find out more at carbonleadershipforum.org. And the hubs are essentially regional groups committed to focusing on the issues related to embodied carbon. I wanted to start out with how you can contact us. I can drop this in the chat later, just so that you can make sure to join up with us via email. That's where we send most of our updates, but we also put out LinkedIn posts here and there, and so that you can join the CLF community, which is a great online forum where you can find out what our hub is doing, but also learn more about what others are doing all around the world related to embodied carbon. There are a lot of it's very easy to submit posts and ask questions and discover new studies. So we always want to start with the very high level of what is embodied carbon, if anyone is joining us who hasn't joined us before. But largely, embodied carbon refers to the carbon emissions that have to do with the manufacture, transport, and installation of construction materials, as well as end of life. We need to update some of our text here, but largely it includes emissions related to all 6 main greenhouse gases. But a lot of people think of it in terms of carbon dioxide. Often we're thinking of carbon dioxide equivalent units, and we could go into a lot more detail. But embodied carbon is kind of what unites Carbon Leadership Forum and what we try to focus these presentations on. So why does embodied carbon matter? A lot of you have seen this a number of times, but the crux of it really is that a very significant amount of our global emissions come from material production and construction. And in the life cycle of a building, actually, embodied carbon can be in the neighborhood of 40% of total emissions. With that, though, I want to jump to the next aspect, which is just to give Victoria, one of our co-chairs, a brief opportunity to speak about Carbon Leadership Forum, how we're integrating with kind of the national group on policy.
Hello, everyone. So very briefly, we have been engaged by the CLF, as Matt just said, the CLF policy group at nation level. And because many states are already developing like policy working groups within their hubs, and they are establishing policy leads. And we are looking forward to form that as well with the CLF Rocky Mountain. For previous conversations, we have heard that many of you are interested on these topics, and we're just looking forward to hear from you. Please email us to the CLF Rocky Mountain Gmail account, or if you don't have it, individually to either of us, and let us know if you're interested on participating in this policy group. And then from that, we're gonna need also one policy lead. And Jim Melentine, actually, he's gonna be attending the first meeting that is gonna be next week, and he will be the one who will coordinate initially with the working group and the policy lead on what the next steps are. But if you are interested, please let us know. We're looking forward to creating this group and work with the state.
Yeah, thanks so much for that, Victoria. And so I will post that email address in the chat once we get started with our presentation with the RMI folks. And just to show you that I did a little bit of updating this slide deck, I did say that this would be the Concrete Solutions Guide, and I did remember to put our presenters' names here. So sorry again for screwing that up on the agenda, but I wanted to introduce two of my former colleagues from RMI, Charles Cannon and Lachlan Wright, who are on the industry team at RMI. They've both been focused on a number of different topics over the years, but right now they are releasing finally a Concrete Solutions Guide that I know they've been hard at work on, along with some of their other colleagues. So with that, I would love to just hand it over to you both. I'll stop sharing my screen, and Charles, I believe the floor is yours.
Thanks so much, Matt, and pleasure to be here, everybody. I'm just going to pull up my slides here, but first, Matt, if you could make me a host so I can do some screen sharing.
Done.
Thank you so much for that. Okay, so I am pulling that up right now. And so can y'all see just the title page of the slide?
Yes, we can. And also, I forgot to make this announcement. Feel free to drop questions in the chat as you go, everyone. We have plenty of time reserved for Q&A at the end. But if Charles and Lachlan feel so inspired, they might read yours during. Otherwise, we'll get to it at the end. But yes, we can see your deck, and go ahead.
Awesome. Thanks so much for that, Matt. And yeah, do welcome questions. Since I'm screen sharing, I'd welcome Lachlan to keep an eye on chat and pepper in a question or an answer if it seems relevant. So my name's Charles. As Matt said, we've been working on the industry side of things as a part of the Climate Intelligence Program, but have been really excited to been working closely with RMI's Embodied Carbon team on this project. And I'm joined here by my colleague Lachlan, one of my fellow co-authors in the Concrete Solutions Guide, which you'll hear more about in just a moment. I hope to keep this presentation brief because I'm really keen to move into Q&A and discussion on some of the topics. We won't be presenting all of the information found in the Concrete Solutions Guide, but hopefully your curiosity will be piqued. So for those of you not familiar, just a quick introduction about RMI is that we are a nonprofit working to transform the global energy system to secure a clean, prosperous, and zero carbon future for all. And this work in the Concrete Solutions Guide was done as a part of the Embodied Carbon Initiative that supports the reduction of carbon embodied in building materials in line with climate targets for a 1.5 degree C world, consistent with the Paris Agreement. And Matt, thank you again for that embodied carbon primer on the way in. That was really helpful. So moving into this Concrete Solutions Guide and what we laid out to do. So we focus on 6 actions to lower the embodied carbon in concrete. And it's important to note our kind of time frame that we chose for this. We focused on mostly market-ready solutions that are already being employed. So there are many different innovations coming down the pipeline of, using hydrogen as processed heat, or really next generation forms of, concrete blends and mixes. But our focus was not on that. There is a sister report, if you will, that was released this week, called The Economics of Embodied Carbon, that focuses on the kind of comparative choices that one would make when trying to lower the embodied carbon in a whole building system, recognizing that just using as much concrete as possible all the time is not always the most direct path to a lower embodied carbon building. However, for this report, we were focusing specifically on concrete. So, big timber fans here as well, but we've been focusing on the concrete supply chain. And it's been written largely in response to the demand for low carbon products and how that is growing, both in terms of, large corporates asking to build more sustainable building campuses for their corporate headquarters, as well as the amount of legislation that we see moving with local buy clean policies, well as the recent proposed federal buy clean as a part of the ongoing infrastructure negotiations. And so this concrete solutions guide highlights 6 different solutions to reduce the embodied carbon, specifically in concrete products, and runs the gamut between processes and technological innovations, as well as softer interactions in between stakeholders. And to go at a high level over all of the 6 solutions covered in our guide and the stakeholders that we hope to address with it, I'll pass over to my colleague Lachlan.
Yeah, thanks, Charles. So as Charles mentioned, the guide is really focused on near-term solutions. And these are the 6 that we came up with in that focus. The first one is really around performance-oriented specifications, being able to allow folks to innovate in terms of the mixes that they're producing in order to lower the embodied carbon of those concrete mixes. And the second one is what that often looks like in practical terms, which is using SCMs within those mixes in order to drive down the embodied carbon and basically not use as much cement to produce the same amount of concrete. The third one is really around sensors, which can have benefits on site in terms of saving time, money, and materials. And that obviously also does have an impact on the emissions, but again, mostly as an enabler really to help people innovate or provide the opportunity to innovate in terms of their mixes, but still be able to get information in real time to confirm the performance of the concrete on site. The fourth one was about embracing circularity, primarily around concrete recycling. So that has a smaller impact on emissions because it's offsetting aggregate, which doesn't represent as much of the emissions in a given volume of concrete. But it has some other benefits, can have cost benefits depending on how and where it's used, and obviously has the main benefit of avoiding a waste stream that would otherwise be a burden. The fifth one is carbon as a service. It's really focused around a sort of new developing area where concrete, CO2, I should say, taken from some other source, like a power station or somewhere else, is used to either used in the mixing or curing of concrete, and therefore sequestered in the concrete itself, offsetting some of the emissions that were associated with the original cement production that went into that concrete. And the last one is really focused on near-term applications at the cement kiln itself. And so there's some longer term issues here. Obviously, whilst we're still calcining limestone, we can't avoid the process emissions, but around a third of the emissions at a cement kiln is associated with the heat source that goes into that, which is primarily fossil fuel sources today. And so the near-term solution is really about fuel switching to things like biomass-based fuels or other waste sources that can be used in the kiln while we wait for some longer-term solutions to come into the market around CCS and zero carbon fuels. So in the guide, just on the next slide, we framed these 6 solutions around the 6 key stakeholders in the concrete supply chain. So unlike some other supply chains, for example, steel, where the emissions are concentrated and there's really only one actor in the supply chain that can make a difference, in concrete, all of the stakeholders in the supply chain have a role to play in reducing the embodied emission in concrete. And so we framed it around these 6 different stakeholders and then linked each of the 6 solutions to which ones are most relevant. So the 6 stakeholders are around concrete producers who have responsibility for lowering embodied carbon, like I said, by innovating in their mixes and deploying SCMs. The cement manufacturers who have an opportunity both to use those alternative fuel sources as well as some producing blended cements, which can also have lower embodied carbon like PLC. The developers who obviously are controlling the budgets and therefore have a lot of influence in pushing the other stakeholders around. The designers who will set the specifications that eventually lead to actions on the ground. Policymakers who can really have an impact across all of the different solutions, both through the procurement lever and through their policy and building code levers. And finally, the contractors who are obviously tasked with actually bringing all of this to life in a final project. So today we've decided to focus the presentation around the solutions we identified as being most applicable for designers. And so with that, I'll hand it over to Charles to take us through the first solution.
Thanks, Lachlan. And recognizing there was a lot of information and interactions there. So for today, we just chose to take the perspective of a designer and what solutions in this guide might they most be interested in. And of those 6 that we originally named, we think that performance-oriented specifications, figuring out how design can be specified in a way that is less prescriptive and allows other stakeholders to be creative in how they deliver on the intent of specifications. The use of supplementary cementitious materials to, as one of our main levers to reduce the cement content and in turn the embodied carbon content in the concrete, and concrete recycling would be of most interest to them. And so to step through that first solution on performance-oriented specifications, just, I won't be able to see everyone's screen pop up just because of my screen sharing, but if you've heard of performance-based specifications, you could go ahead and just throw an emoji up of your choice in the bottom Zoom panel. And I ask this because, performance-based specifications is a relatively well understood term, whereas performance-oriented specifications is a term that we coined mostly for the sake of this report. So performance-based specifications talk about when you specify, when you lay out a specification, have it be based on the performance, the end goal of the concrete, rather than a specification of what it is made out of. So saying must be 15% fly ash is a prescriptive specification versus must have a compressive strength of X is a performance-based specification. And over the years, performance-based specifications have kind of caught on to mean only performance specifications, not in fact performance-based. And so we chose the term performance-oriented to kind of step away from this misnomer that performance-based is not wholly performance specifications, but rather that there is this blend of prescriptive specifications and performance-based specifications. And that's valuable to note because, when specifying projects, it's important to give deference to the experts in the field who have been working on a particular project in a particular space. So if you were, for example, doing a bridge retrofit and the township had recently worked on the bridge like in the last decade, and they had experimented with different concrete blends and realized what didn't work, or that, based on the weather conditions, they want a specific blend, it's, perfectly acceptable to have a prescriptive specification on elements of a building project. Rather, wherever possible, introduce a specification that is based on performance, because that allows creativity in other stakeholders, whether it be the contractor or the concrete producer, to meet the intent of the specification. And one example of this that's happening in Colorado right now is with the Colorado Buy Clean legislation that specification on the global warming potential, the embodied carbon in the material, is a performance-based one, in that it says not to exceed a given number. Now, there is a question, and I'd be keen to get to this during the discussion period, of what that means for other specifications going forward in Colorado State, or even more local city projects. With this first performance-oriented specification of global warming potential or embodied carbon in place, is that going to pave the way for more performance-oriented specifications to be used in the future? Curious if any of y'all have thoughts about that when we move into the Q&A and discussion section. But for right now, I'll pass to my colleague Lachlan to move through our next two solutions.
Yeah, so the next one we have here is around the use of SCMs, which is often the practical implementation of allowing those performance-oriented specifications, is allowing folks involved in the supply chain to innovate by using SCMs in the mix in order to lower the embodied carbon. So in putting together the guide, we had a look at both some of the practical constraints around using SCMs. So thinking, for example, in limestone about the limits that ASTM sets out for how much limestone could be used in a mix because of the impact that it might have on strength, as well as some of the supply constraints, particularly that's focused around fly ash and slag. And together, looking at those two constraints, we come up with the estimate of around 40% substitution being possible across the US with SCMs. And that in of itself, because it offsets cement usage, would have the largest impact in terms of emissions of any of the 6 solutions in the guide. So here we're talking about 27 million tons of CO2 per year that could be offset if we could reach that 40% substitution. In terms of those constraints, in order to reach that 40% estimate, we basically used the ASTM limits on limestone, which is 15%. And then both fly ash and slag are supply constraint limited. So in terms of slag, that's pretty severe supply constraint. There's only a few primary steel mills left in the US, all of them in the Midwest. And so regionally quite constrained, and the total volume is not that high, even though it can substitute a large amount of cement in a given mix. For fly ash provides probably the most opportunity for upside in terms of increasing the amount of SCMs that are being used. So there has been a decrease in the amount of fly ash that's available, and that's associated with coal-fired power plants obviously being shut down. And that's what you can see in the map here is what's remaining in terms of coal-fired power across the US. And that's led to some regional differences as well. So you can see on that map that there's still quite a lot of coal-fired power and therefore fly ash available in the east, but less so in the west. And in Colorado specifically, there are still a couple of large coal-fired power stations, including the Comanche power plant. So what that means is that even though the amount of fly ash used in concrete has stayed relatively stable across the US at around 15 million tons per year, the fraction of total fly ash that's being used is increasing because the supply is dropping off. So at the moment, around 50% of the fly ash that is produced across the US is used, recycled into producing concrete. There's an opportunity to obviously use that remaining 50%, but then also some other sources that can lead to higher substitution limits. So over the past 20 years, there's around 600 million tons of fly ash that's been stored on these coal-fired power plants. And there is an opportunity to reclaim that material and use it in concrete. And there are some projects already ongoing in that space. Boral, for example, has a reclaimed fly ash product. In addition to that, there's also some potential new sources coming onto the market. So there's natural pozzolans, which are currently being mined in Nevada, which can supplement and provide additional supply. And there's also some new waste product pozzolans, for example, crushed glass, which has been used in a number of projects in New York. And of course, all of these solutions have been around for a while, and that's exemplified in the Colorado example on the slide here around DOT using PLC in their highway replacement projects. But mostly from an emissions perspective, the aim with SCMs is to increase their usage as much as possible. So on the next slide, is the third solution, which is around concrete recycling. So as I mentioned earlier, concrete recycling has a smaller impact in terms of emissions because it's offsetting new aggregate rather than any of the cement, which is where most of the embodied emissions are coming from in a given concrete mix. But it does have some other benefits. So if it's used on site, it can offer cost benefits. If it's used on the same site where it's produced, often those cost benefits are negated once the material has to be transported any significant distance. And obviously it avoids the waste stream that would otherwise be in place. It is important to note on concrete recycling that from an emissions perspective, it needs to be used in non-structural applications in order to have an emissions benefit. Because of the variable nature of the material and the size and grading and potential for mortar to be left on the material as well, it can have a negative impact on the strength of a concrete mix. And if that's the case, any additional cement that's used in the mix will offset any benefit associated with the emissions reduction of using recycled concrete because it is relatively small. And that's been recognized in a number of areas, which is the example on the slide here around the city of San Francisco specifying 15% RCA, but only in pavement applications. And similar to SCMs, this is a relatively mature solution in that there are a number of companies across Colorado that offer recycling services. And it's really about maximizing the amount that it's used in order to drive emissions reductions. And so with that, I'll hand it back to Charles to close out.
Thanks, Lachlan. And so, what we want to underline in this report is that, reducing the embodied carbon in concrete is far from an intractable problem. And in fact, opportunities abound for decarbonizing this industry using proven and scalable technologies. And again, Lachlan had mentioned this earlier, but a really unique opportunity here in the concrete sector and indeed in the built environment is, a bit of a double-edged sword in that one, there's a challenge that so many building projects are very specific and with a very specific set of stakeholders. But the opportunity in each and every project for any of those stakeholders to engage in conversation early, begin a dialogue around the opportunities that exist in many of these proven solutions is sizable. And so it's our hope that by members of the industry engaging with this guide, we'll be able to foster collaboration among stakeholders that will, drive adoption of these solutions, but also further innovation for a next generation of lower embodied carbon building solutions out there. And with that, we're happy to pause and move into questions and discussion.
Awesome. Thank you both so much for that. And I have a not even a softball, just a logistical question that came up in the chat earlier. Can we share your slides with everyone after all is said and done?
Yes, I'd be more than happy to share the slides. And also I'm happy to pull up some links to the Concrete Solutions Guide now and just link it in chat so you can go have a look-see at the report for yourselves.
That would be great. So I see a few comments in the chat, but not necessarily direct questions for our presenters. So feel free to either use the raise hand function if you want to ask a question directly, or drop a question in the chat. Until that point, though, I will just ask my first question here, which was, so one thing a lot of people have on their minds in Colorado is the new Buy Clean legislation. I was just curious, in your mind, how can this guide kind of act as a supplement, something that can kind of, assist the people who are tasked with carrying out what is in that legislation, whether on their projects or whether they're policymakers kind of looking for the next thing?
Yeah, that's a great question. So I would say that a lot of the solutions on this guide focus on accessibility, and that the main impact of Colorado Buy Clean is setting a maximum global warming potential for building products, notably concrete. So there's a question of, if you're submitting a bid, your boilerplate design or your go-to concrete blend, what is the embodied carbon of it, and if it's over that specified in Colorado BiClean, a number of these solutions could serve to benefit in how to reduce those emissions. Or taking another perspective, if you're a contractor who's would have to work with more and different concrete blends as a result of lower embodied carbon blends being more prevalent, you could look to solution 3, which uses on-site sensing to be able to understand the exact curing rate of the concrete on site, different than kind of standard cylinder testing that the industry does currently, so that you can be more confident that your concrete is curing at the appropriate time and you're able to advance to the next phase of work.
I am muted, but thank you for that response. I also wanted to note something kind of related to that BiClean topic. I'm just reading through the chat now. So Rod had posted just that the Office of the State Architect is in the process of posting a position funded by the legislation. And so this would be focused on the state's BiClean efforts. So if anyone is interested or capable in that regard, check out that posting or reach out to Rod. The next question in here, it's a bit more specific, but perhaps you could take a stab at all or part of it, from Will Nash. What baseline mixes are used for the limits to GWP of each mix? They've reviewed the NRMCA standard mixes and found them to be out of date and too generous to be used as baselines. Additional question, what incentives are recommended for concrete suppliers to go beyond the baseline limits?
Yeah, so I'll let Lachlan speak to the standard baselines that we identified in our ASTM mixes, and then we'll take a turn at that second part of the question.
Yeah, in terms of the overall emissions reductions that we were looking at here, so in order to arrive at that 27 million tons for the 40% substitution, what we were comparing to is looking at the overall US consumption in terms of cement, which comes from the USGS, the slag consumption, again from USGS, and the American Coal Ash Association, which has data on fly ash. So what that all means is that if you sort of aggregate all of that up across the US, we're talking about 15% substitution as sort of the baseline average mix. And so then we looked at the embodied carbon associated with each of those components to come up with the overall baseline, and then look at the difference between that and the 40% maximum that we thought was possible.
Yeah, and so, that's to say that we are using, ASTM spec type 1 variants from back in 2012 that I think are the kind of out of date and too generous to use as baseline. So first, to say that there's tremendous reduction potential from just using those existing mixes that have been around for a while. But to your question of what incentives are recommended for concrete suppliers to go beyond the baseline limits. So there's one, of course, is policy, and there's an interesting policy that's passed the House, I believe, in both New York and New Jersey, called LECLA, that actually provides like a 5% cost discount to the lowest embodied carbon bid that is put forth. So that's aside, instead of setting like a ceiling for global warming potential, rather saying if you produce the lowest embodied carbon bid, driving competitiveness between manufacturers, there can be an opportunity to get a cost discount there, as opposed to having to like annually reset the baseline. So that's one policy incentive to spur concrete suppliers to go beyond the baseline. The other, I think, is an economic one, because cement is often the most expensive material in a concrete blend, and most lower carbon concrete blends will, by definition, have less cement in them. So the testing process for introducing new blends into a market are significant. You know, it takes time and resources as well as infrastructure. I think I saw another question in chat around silos for holding SEMs. You know, that upfront commitment can be costly and take time, but once that is introduced to the market, it's you know, there are returns in being able to use less cement in your product. There can be cost savings that can be realized there.
Thank you. And I hadn't heard of that LEPLA kind of 5% reduction in the bid when it's being evaluated. That's a smart way of doing it. Let's go to Harrison, who has their hand raised first, and then I'll keep going into through the chat.
Hi, yeah, thanks. Yeah, kind of off that same comment, same question about whether current limits are maybe too achievable or set too low. Does anyone on this call have any context as to why California's Buy Clean recently pushed back their implementation dates, and if it has anything to do with these limits of maybe being, I don't know, too strict, or does anyone have any context for that and how that might play into Colorado's Buy Clean?
So I could take a first pass, and of course welcome any insights from anyone else on the call. But you know, interestingly enough, California Buy Clean does not have concrete as a listed product. There was some lobbying that went on at the introduction of that. So you know, I feel that I could say with relative confidence that it's not these kind of substitution limits in the concrete space that's rolling back California Buy Clean, considering that concrete isn't a focus in that legislation, but you know, rather could just generally relate to the you know, changing infrastructure when changing products, and the tension between wanting to start to move that forward and availability of supply. There could also be a question of, you know, if the manufacture of low carbon goods is happening outside of California, they have an incentive to wait and allow for manufacturing inside the state to develop so that there's, you know, more economic generation there. That's more of an opinion's my own question, a little bit outside of my area of expertise, but that is a first pass.
Yeah, that makes a lot of sense. And if does anybody else have context around why they've pushed some of those implementation dates back? I'd welcome anyone else to come off mute if they have specific knowledge. Not, I'm happy to charge ahead. So we have a good number of questions and comments in the chat. So there was a question about, are there developments using resistive electricity in kilns? Maybe more broadly, I'll ask Lachlan and Charles just to comment on what technologies you've seen. I know one of your chapters was on, you know, quote unquote, green heat for kilns. So all electric options and other options, what are you seeing? What's prevalent? What's, you know, kind of still on the lab bench?
Yeah, so more broadly in terms of the electrification of heat, at the moment, the most commercial technologies that you can get off the shelf basically have reached insufficient temperatures for concrete applications. So we're talking 1,300 degrees in the kiln, and anything above about 1,000 at the moment is still in a research or pilot phase in terms of using electrification to directly produce heat. And part of that is cost, and part of it is just technology readiness level as well for some of these different types of applications.
Thank you. And outside of electricity too, you know, is there anything else that seems promising that's not just, you know, maybe a greenwashed fossil fuel?
Yeah, so I mean, the other main one is obviously hydrogen, right? Green hydrogen in particular. So we've seen announcements of, you know, gigawatt scale hydrogen projects, not specific to the concrete sector, but hydrogen has application in many other sectors. And there are some folks that have been working specifically on using hydrogen as a heat source for these high temperature use cases. In some cases, there are other technology problems with using hydrogen for high temperature in that it actually burns too hot. And so you can end up requiring a lot of expensive materials in terms of the burner and stuff like that. But Toyota, for example, had a program where they were looking at redesigning burners so that they could use hydrogen in them and overcome some of those temperature issues. And then once there's a sort of generic burner on the market like that, obviously Toyota is interested in metals smelting applications, but that can be applied more broadly to high temperature heat.
Yeah, and then lastly, outside of electrification, a solution that's a little more readily available is to use biomass. Of course, biomass has its own questions around sourcing and subsidy, but if you're choosing between biomass grown on marginal farmland or coal, the choice becomes rather clear. And there's an opportunity to blend that into existing processes without so much great technological change, as well as good old energy efficiency upgrades in kilns. There's some stats we have in our report around the EPA benchmarking cement kilns, and there's still being plenty of opportunity to make common sense efficiency upgrades there.
Great, and it looks like we got a related question. Do you have any specific comments on electrolysis of limestone, or is that not something you looked into?
No, it's not something that we've covered in the guide. Obviously, the electrochemical technologies more broadly are being applied. We see early research in steel in the same sort of area, trying to overcome the same sort of problem with molten ore electrolysis, but there's just a lot more technology development need to be done there. And as Charles mentioned earlier, we were mostly focused on near-term solutions.
Mm-hmm. And so the next one, Charles, you referenced this before, but there's a question about, would you suggest that people purchase storage where fly ash is currently not being used? This person heard that many times there's not enough fly ash available, but in your report, you said that in some cases there's a surplus. So could you just comment on both of those things?
Yeah, so I would say first that, for a concrete producer to offer blends with more fly ash in it or other, low carbon concrete blends, they need to invest in the silo to store it on site, which comes at a capital cost as well as any testing associated with it if it's not proven in the market. And for a concrete producer to make that leap, there needs to be a clear market signal, and hopefully Colorado Buy Clean will help to improve that. And the jump for individual concrete producers to make that investment in storage will become more readily seen. But I might pass to Lachlan on the kind of storage versus use statistics we've been seeing.
Yeah, we heard this same feedback around, as Charles mentioned, having to do the CapEx investment associated with the storage and potentially seeing this problem becoming more prevalent, mostly because of the power system dynamics. So if we have more renewables coming on and coal-fired power plants are becoming more seasonal in their operation, that means that we get peaks in fly ash production. So as Charles said, there is a CapEx investment associated with that, but some of these other supply sources could also potentially help with that, right? So if we're thinking about reclaimed fly ash, that it's not coupled to power production in terms of how quickly we need to take that fly ash back from the existing ponds where it's stored. And similarly for a natural pozzolan that's coming from a mine, we have more control essentially on the upstream supply side about how quickly we produce that and at what time. And so there's an optimization there between that supply side and what amount of storage is needed at the ready mix.
I'll ask the next two questions that have been sitting for a while, and then Scott, I'll get to your raised hand. So on a related note, did you do research into other SCMs aside from fly ash, and if so, what did you find?
Yeah, so the natural pozzolans and other waste materials like glass that I mentioned earlier, ground glass, were the main sort of things that we found that were available in the market and ready to move. We did look at some more exotic type materials, and obviously there's cost impacts associated with that. So we mostly tried to focus on obviously the big three that are already in the market and the ones that are near term in terms of natural pozzolans and ground glass and other waste materials. I don't know, Charles, if you had anything else.
No, just to be clear that we looked mostly at limestone, fly ash, and blast furnace slag, and that, limestone certainly very much readily available, but of course is usually only added up to 15%. There is experimentation with adding it further, but it does begin to affect performance at that rate in standard blends.
Yeah, that makes sense. I'd like to dig in more on that, but I also want to get to all of our questions. Judith asked, what are the opportunities for concrete to be recycled in the US? So I know this was one of your big recommendations. It'd be great if you could talk, I think, generally about the market and how much this is actually being done.
Yeah, absolutely. So, buildings are torn down all the time, and new buildings are regularly put on top of them. So what is to be done with the concrete that is removed from a given site? Now, it's very easy, and as Lachlan has noted, economical to use it, to crush it up on site and use it as gravel, to use it as an aggregate in non-structural applications. Past that, there's yet to be advances in using recycled concrete in as aggregate in structural concrete applications. And the reason that happens is there's mortar existing in the concrete that is inconsistent and does not behave consistently when put into a new concrete mix. With the addition of lots of different supplementary cementitious materials, the challenge that comes up is once you start adding enough of them, there are cases where there are synergies, particularly with fly ash in concrete mixes, where it improves performance. But with a number of other supplementary cementitious materials like limestone and like the recycled concrete aggregate, there's an interaction that can occur that would require you to put more cement in to account for the performance, in which case, it's not really as great of a net benefit. Lachlan, I don't know if you have anything else you want to add on recycled concrete.
Yeah, maybe the only other thing to say is there are some potential improvements coming down the line, particularly an interaction between using CO2 in part of the mixing process and whether the existing recycled concrete aggregate can also provide a host material essentially to store some of that CO2 and to get a larger benefit by combining the two solutions. But as Charles said, there's still a lot of work to be done in that area, proving what the strength impacts are and what the emissions impacts of that process overall will be as well.
Definitely. And in the chat, Jay added on durability concerns with chloride ingress are important to consider as well. I'm going to jump over to Scott, who has his hand raised, and then we'll jump back to the chat.
Hi, I hope you can hear me.
Yes.
Cool. Yeah, one of the big concerns about cement kilns is air toxics. It's not entirely on topic to embodied carbon, but I'm going to try and relate it a little bit. So cement kilns generally operate as unregulated toxic waste incinerators. It's heavily incentivized. They get good sized tipping fees to take this waste and relieve the generators of their responsibility. So that's a big incentive for them. So many of these waste fuels are not high energy intensity, so they need to add other high energy intensity fuels to make up for it. I'm wondering if EPDs take that into account at all. I'm guessing that it's totally swept under the rug, so that there's additional embodied carbon when you have to add additional high energy intensity fuel to make up for the low energy intensity fuel qualities of a lot of hazardous and industrial waste that gets put into these kilns.
Thanks for that, Scott. To your question on EPDs or environmental product declarations and how they address non-carbon impacts, I would definitely recommend checking out the EC3 tool, originally formed by the Carbon Leadership Forum, which is a kind of online database of EPDs, and you should be able to explore what non-carbon inputs and questions they have in those fields. As it relates to non-carbon inputs, unfortunately, it wasn't something that we looked at in this work, but as a part of RMI and indeed our climate intelligence program, we do intend to look into non-carbon impacts. We have a team that works on methane emissions, for example, as it is a holistic effort in determining the impacts to the climate.
But you don't think that they're trying to compensate on the EPDs for the additional high energy intensity fuels that's needed to be added to compensate for this hazardous waste?
Unfortunately, I couldn't speak to that right now based on the research we've done so far. Sorry.
Yeah, I think we'll keep jumping so we can get through our questions, but yeah, it's a little outside the scope of the report, but I appreciate you giving it a go there. So I wanted to bring up, I know that there were a question or two before this, but there was a question from Bob about the recent IPCC report. They say that carbonation can reach 50% of cement emissions. Did RMI consider this at all as a potential solution? And I don't want to put you totally on the hook on this. I asked Jay Earhart to speak to this as well, but Charles Laughlin, did you have any thoughts about carbonation first?
Sure, yeah, I'll speak to that briefly, recognizing that we have Carly from Carbon Cure on this. So if we bungle the specifics on technology, do please correct us. But we think carbonation and sequestration in concrete is a really promising technology that we have named as one of our solutions, and we think is also incredibly valuable in that so swiftly in the last few years that it's come online, it's been able to change the perspective and attitude of many stakeholders in the space towards embodied carbon, because there is a cost benefit, because there are in some cases performance benefits. In our report, we lean heavily on a Nature article that has done a study on various carbonation methods over the year, and has determined that where you source your CO2 is really important, and that for a sector this young, that sourcing can be a challenge at times. That said, we've also seen that introducing CO2 in the mixing process has had consistently more positive and more consistently positive benefits than CO2 sequestration in the curing process, which is a little bit less of a controlled environment. Lachlan, I don't know if you have more thoughts you want to add, or if we should pass to Jay.
I think you've covered it.
Great. Well, Jay, I know you have some thoughts here, so.
Yeah, so I know that there's that one, I forget the exact name of the PopSci article that's been going around. A lot of people have been sharing it with me about concrete carbonation. So the IPCC is referencing that 50% number for carbon uptake due to natural carbonation. And that is due to just the direct emissions from the cement manufacturing. So just the calcination of your limestone, your calcium carbonate to calcium oxide is some of the emissions. Those are the direct emissions, not including any of the heating of the kiln, any of the electricity. So that's where that 50% number is coming from, is about half of the CO2 emissions from that calcination you're able to reabsorb. That's not taking into account all of the emissions in the whole life cycle of cement. So we're showing through some of our research here at CU Boulder that we can get up to 18% depending upon your mix design, but maximizing the uptake that you get from a particular mix design is not the best solution when you take a life cycle approach. You actually want to minimize the amount of CO2 that can be uptaken by your concrete in situ, by using SCMs, which reduce the carbon uptake because your life cycle emissions are going to be lower from that. So in that natural carbonation process, the key takeaway is don't maximize the amount of CO2 that you can uptake, because that's actually a net detriment. And so that's where, there's some conversation going on right now about that. I'm happy to speak to that more if you'd like.
Yeah, that's a great point. And I know that you kind of touched on this at the beginning, Jay, but just again, drawing the difference between kind of the natural carbonation process, which is where, CO2 is being sequestered in concrete through, from the atmosphere or from the whatever the air of whatever space that concrete is located in, as opposed to the process that a company like Carbon Cure might go through, where they're, that happens, but they're additionally injecting additional CO2 into the concrete as a form of sequestration. So those are similar but different. We are pretty much at time here. So I wanted to give just look to Charles and Lachlan really quickly, see if you had any parting words before we say goodbye.
Well, I want to say thank you, Matt and the Carbon Leadership Rocky Mountain Hub team for having us, and also everyone for their questions. Jay, I particularly appreciate you kind of putting your finger on the interrelationship of all these different pieces and materials as one moves through the supply chain. And I think our hope with this guide is that many of the conversations and the specifics can be discussed towards the application of a specific project, because in the midst of these discussions, some really great opportunities for lower and more lower carbon and lower cost projects can emerge.
Thank you for those parting words, and totally agreed. And Jay, thanks for letting me put you on the spot. That was helpful. So I just dropped a few links in the chat again. So please save those if you want the link to the Concrete Solutions Guide. I'm pretty sure if you just Google RMI Concrete Solutions Guide, you'll be just as good. And to our contact info. And like I said, we'll get the slides out to everyone. We'll talk to Charles and Lachlan about that. Thank you all so much for joining, and enjoy the rest of your week.